1991. Find the middle index in array question. So we are given a 0 indexed integer array nums. Find the leftmost middle index, that is the smallest amongst all the positive ones. So a middle index, it's also given about the definition of the middle index. So what is this middle index? A middle index is an index where nums of 0, nums of 1 plus nums of 0 plus nums of 1 plus etc plus nums of middle index minus 1 will be equal to number nums of middle index plus 1 plus nums of middle index plus 2 plus etc plus nums of nums.length minus 1. So if we find the middle index at the very left end, that is if middle index is equal to 0, then the left side sum is considered as 0, and the same thing is applicable for the right side, that is if middle index is equal to nums.length minus 1, the right side sum is considered to be 0. So return the leftmost middle index that satisfies the condition, or minus 1 if there is no such index. So let's check the example. So first example, the nums is given as 2, 3, minus 1, 8, 4. So here 8, the third index 0, 1, 2, 3, the third index 8 is considered as a middle index because 2 plus 3, 5 plus minus 1 is 4. So the sum to the left of this middle index is 4, and to the right of the middle index, that is 4, and those two sums, that is the left part sum and the right part sum with respect to the middle index is same. When we look at the second example, here the 4 is considered as the middle index because to the left part of the 4 it is 1 plus minus 1 is equal to 0, and to the right part, as it is already explained here, if our middle index is nums.length minus 1, then the right side sum is considered as 0. So here the right side sum is considered as 0, and that's the 0. That's why the index 2, that is this 4, is the middle one. Now 2, 5. So suppose if we are considering this 2 as the middle index, that is 0 as the middle index, then the sum to the left is 0, but sum to the right there is 5. So 0 is not equal to 5. So this index 0 cannot be the middle index. Now if we move to the next index, that is 1, where nums of 1 is 5, sum to the left is 2, but sum to the right is 0. So there is no such middle index that satisfies our given condition in the question. So the answer is going to be minus 1, as there is no valid middle index. And the other special case is if we are having only single element. If we are having only a single element, then that single element will be the middle index, because to the left it is 0 and to the right it is 0. So how we are going to do this problem? So let's consider the first example. The first example is nums is equal to 2, 3, minus 1, 8, 4. So here when we take the sum, like 2 plus 3 plus minus 1, and 8 is the middle index, and the right side is 4. So this is why this third index comes to be the middle index, because here the total sum is 4 and here the total sum is 4. So LHS is equal to RHS, that is left hand side is equal to right hand side. Suppose if we find what is the sum from this left to right, like the cumulative sum from left to right. Let's say left cumulative sum. So if we find such that, we can check whether we will find any relation, whether we will find any intuition to get the result. So left some cumulative sum. So the first value is 2, then it will be 2 plus 3, which is 5, then it is 5 plus minus 1, which is 4, then it is 4 plus 8, which is 12, and 12 plus 4 is 16. So this is when we consider the sum from left to right. Now same way, let's also try a right to left. So right cumulative sum, which is equal to, let's come from this right, let's start from 4 and fill this array from right to left. That is, we start with 4 and then 4 plus 8 is 12, then 12 plus minus 1 is 11, then 11 plus 3 is 14, and 14 plus 2 is 16. That is what we are actually doing, means we will be doing right sum of length, that is actually we will be storing right sum of length minus 1 is equal to nums of length minus 1, and we will be traversing from for I is equal to length minus 2, I greater than or equal to 0, I minus minus, and this right sum of I will be equal to right sum of I plus 1 plus nums of I. That is, we are filling from right side to the left side. So when we so this is the two values that we get after applying this. So our left cumulative sum is 2, 5, 4, 12 and 16. Our right cumulative sum is 16, 14, 11, 12 and 4. So if we check this, the third index is we are getting as same value. So it means that it's the equilibrium point that we are looking for. So we just need to traverse again and just check for which of the index the left cumulative sum becomes equal to the right cumulative sum. So after finding this, we just need to find the index where left cumulative sum become equal to right cumulative sum. So that's what we have to do in this problem. So let's try this approach. So let's deal with the single element case first itself. If nums.length is equal to 1, then it is just 0. Now what we are doing, we need left part sum and right part sum. So int let the length be nums.length. So this is left part sum, which is equal to new int of length, and int right part sum, which is equal to new int of length, same as that of the input array's length. So now find the left part cumulative sum. Okay, so left part sum of 0 is equal to nums of 0. Now we start traversing for int I is equal to 1, I less than length, I plus plus, and our left part sum of I will be left part sum of the previous element, that is I minus 1 plus nums of I. Same way we are going to find the right part cumulative sum. So right part sum of as we told, here we are filling from right to left. At first the rightmost, that is if this is our element say 1 2 3 4, something like that. We will be filling first from 4, then 4 plus 3 equal to 7, then 7 plus 2 equal to 9, then 9 plus 1 equal to 10. That is from right to left. So right part sum of length minus 1 will be the very last element. Now go from right to left. For int I is equal to length minus 2, I is greater than or equal to 0, and I minus minus. So right part sum of I will be equal to the sum of right part sum of I plus 1, the very first next element, plus nums of I. So now we filled both right part cumulative sum array and left part cumulative sum array. Now we just need to find the index where we have equal value. So for int I is equal to 0, I less than length, I plus plus, if left part sum of I becomes equal to right part sum of I, we just return this I. So if we are going to find any such index where left part sum of I equal to right part sum of I, then that is our middle point, our equilibrium point. So we will just return this I. Otherwise we will not be going to find any middle index, so we will return minus 1. So let's check with the other sample test cases. Let's submit. So when we are talking about the time and space complexity, here we are going through the array once. Here again we are traversing through the array once, and here also once. So it basically n plus n, which is big of 3n, which is same as big of n. In case of space complexity, here we are using extra space of size big of n. Here also big of n plus n, it's big of n itself. So space complexity is big of n and time complexity is big of n. So this what this problem is.